In this video, we'll take a look at R group decomposition using Lead Discovery ChemCharts. To demonstrate the R group decomposition, we have a set of molecules extracted from ChemBall, all of which have a common pyrimidine core. These are displayed in the ChemCharts table in Spotfire. R group decomposition is accessed via the Lead Discovery ChemCharts chemistry visual, so we'll add a new Lead Discovery ChemCharts visual and navigate to the chemistry chart. Here we select the Chemistry Analysis tab at the bottom of the visual and choose to add a new R group decomposition from the drop-down. This will open the R group decomposition dialog. First, we need to define one or more core substructures. For this simple example, I will just draw the pyrimidine core. However, in more complicated datasets, you can define more than one core, and you can also use query features like wildcard, atom or bond types. Next, we need to select the structure column containing the molecules. In this case, we only have the one structure column in the data table. We can choose the format of the columns that are output from the R group decomposition. This is useful if the input column is a structure format that contains 2D coordinates. Choosing molefile here will preserve those coordinates in the output columns. We'll take a look at some of the other options a bit later. Clicking OK will start the R group decomposition. Once complete, the data table now contains the results of the decomposition. In this case, we have a column containing the core identified in each molecule. There are also 3 R group columns, each showing the R group at one of the 3 automatically identified substitution positions. Notice an item has been added to the chemistry visual that represents the Spotfire data function for the R group decomposition. Just like the structure searches and property calculations, you can display the details, edit and delete the R group decomposition using the controls at the top of the item. In this example, we did not include the substitution points when we defined the core, which led to the substitution points being automatically determined and labelled R1, R3 and R2 going anti-clockwise around the core. It is possible to explicitly define substitution points and the labels used to denote them. To do this, we'll edit the core in the existing R group decomposition by clicking the Edit button at the top of the decomposition item. This will open the R group decomposition dialog for editing. Next, we will augment the core definition by explicitly defining the substitution positions R1, R2 and R3 going anti-clockwise around the pyrimidine ring. After clicking OK, we can see that the R group decomposition has been rerun. Only this time the substitution points are labelled as the user defined and the corresponding R groups are in the appropriately labelled columns. In this final example, using another dataset from ChemBall, we will draw a core with 2 defined substitution positions, but this time we will check the Only Match R group atoms defined in core option. This ensures that only molecules that have the exact substitution pattern defined in the core are considered for decomposition. After running the decomposition, the effect of this setting is illustrated. The molecule in the first row matched the core, and you can see the result of the decomposition in the core, R1 and R2 columns. The molecule in the second row did not undergo decomposition, as there is a fluorine substituent that is not in one of the explicitly defined substitution positions in the core. Thanks for watching, and be sure to check out the other how-to videos for Lead Discovery ChemCharts.